This is section 3.1, relating graphs to events. Our objective today is to interpret and sketch graphs that represent real-world situations. Let's start with our vocabulary. Linear is when a change in data forms a straight line when graphed. Nonlinear is when a change in data does not form a straight line when graphed. Got a picture of each one here for you. The one on the left is your linear because it makes a line. The one on the right is nonlinear because it makes a curve. So let's look at it interpreting a graph. So the graph shows the altitude of a helicopter during a flight. When is the altitude increasing? So increasing is when it's going up. We always answer these questions based on our bottom axis, which is usually time. So it's increasing this whole area right there from 0 to 10 minutes. So we'll say 0 to 10 minutes. When is the altitude decreasing? Well, when's it going down? It's going down over here. That's from 10 to 20 minutes. When is the change in altitude linear? Let me erase the lines I just drew. So linear, it makes a straight line. It makes a straight line here and over here. We have to do those separately because they're separate straight lines. So we have 5 to 10 minutes and 10 to 20 minutes. And when is the change in altitude nonlinear? Well, we've got a little curve right here, so that's 0 to 5 minutes. All right, a couple questions for you to try to answer. Same graph, answer these questions. So what is happening in the first 5 minutes? So your answers could vary here. For the first 5 minutes, he's going up kind of rapidly at first. Go up rapidly at first. And then the first 10 minutes, he kind of steadies out. So he goes up steadily then. So what could be different from 0 to 5 and 5 to 10? There could be all sorts of different answers. You get to get creative because we don't actually know, we're just speculating. My guess would be that they had to go over a building. Because it's a helicopter. They had to take off quickly to get over a building and then they could steady out. What happened at 10 minutes? Well, at 10 minutes, that's the peak. You could get creative here, or you could just say they started going down. And what happened from 10 to 20 minutes? You could get creative here again, but we could also just say that they went down steadily. If you're getting creative with your answers to these, just make sure that your answers kind of go along with what I've said here. Let's look at this example. We're talking about a bird here. So when does the bird take off? Well, I've got time in seconds and altitude over here. Altitude is how high up you are. So it takes off, it leaves the ground right away at the start at 0 seconds. When does the bird land? You go up in the air and then you come back down. Your altitude is 0 again when you land. That's right here at the end. That's at 20 seconds. Over what interval is the bird rising? When is he going up? Well, he goes up from 0 to 5 here, so 0 to 5 seconds. Over what interval is the bird heading towards the ground? Well, he was going down for 5 to 20 seconds. What happens at 5, that should say seconds? Well, at 5 seconds, you could get a little creative, or you could just say that the bird starts going down. And then what happens at 15 seconds? Something happens to make him steady out, and he goes down steadily now. So maybe he goes in for a landing. Wow, that's not what that says. There we go. A landing. There we go. All right, let's try this one. Kim measured her pulse rate occasionally during a 45-minute workout. The workout included a 10-minute warm-up period and a 10-minute cool-down period. Sketch and label a graph showing her pulse rate during her workout. So for our graph, we need our two axes. The bottom will be time in minutes, and the side is going to be her pulse. Well, we're given some time. It's a 45-minute workout, so I'm going to do this in fives. 10, 15, 20, 25, 30, 35, 40, 45. All right. So sorry, we forgot to title it. Let's call it Kim's Workout. All right, so in the first 10 minutes, she was warming up. So her pulse doesn't start at 0. It probably starts right about here. It's going up steadily, but slowly. She's going to work out for this middle 25 minutes. So her pulse is probably going to jump up pretty fast, and then it's going to steady out, but it's going to, kind of bob and weave back up in there. And then she has a 10-minute cool down, so she's going to go down steadily and slowly. That is a graph that could look like what Kim's workout looks like. Yours might be slightly different, and that's okay. So you're going to try this one. John was walking his dog to the park. He started by jogging for 5 minutes, then took a short 2-minute rest. After his rest, he walked a bit further for 10 minutes, and finally sprinted all the way home, which took him 10 minutes. Create and label a graph that describes John's distance from the park during his walk. I apologize, there's one typo. This should say all the way to the park. So try making this graph. On his graph, we'll have time at the bottom in minutes. And on the side here, we're going to have distance from park. All right, let's sketch our graph. So he jogs for 5 minutes. But notice that he's going to start at home if he's going towards the park, so he's starting far away from the park. So he's jogging for 5 minutes. Then he took a 2-minute rest, so he flattens out for 2 minutes. After his rest, he walked, so he's going slowly, and then he sprinted. There's a picture of what his walk to the park could look like. I forgot our title again. We could say John's trip to the park. All right, so there is our finished graph. Here's your assignment.